Good day. My name is Dmitry Vilbaum, and I'm CEO of Terra Insight Services, Inc. and Terra Energy and Resource Technologies. We utilize our in-house technology STeP, or subterranean prospecting, to find oil and gas or to supplement the traditional G&G data sets such as 3D seismic and well control. This case study deals with the comparison of Terra's STeP conclusions with the 3D data set and the subsequent drilling results. This project, Genius 2, was generated for a 231-acre area in Louisiana. The initial well, shown by the yellow arrow, was drilled to test the Frio 8000 sands and produced 2,400 barrels of oil and 66,000 MCF of gas before watering out. The subsequent 3D seismic acquisition and interpretation concluded the initial well was low in structure, and a new well to be sidetracked from the original surface location was planned to be 35 to 40 feet structurally higher to the initial well. The structure map shown here is a result of the 3D processing and interpretation. The proposed drilling location is shown to be high on structure according to the 3D seismic data set, and also supported by an amplitude anomaly that is also confined or coincides with the structural contours. The objective was to survey the area using our STeP technology and to validate the G&G generated prospect. The images shown here are the information utilized to generate the prospect, including well logs, 3D seismic time and depth structure maps, amplitude anomaly maps, as well as varying time slices and cross sections that were also tied to the relevant well logs. In short, the prospect was put together according to the high quality standards of G&G. The three-dimensional lithological cube generated using the STeP technology during its visualization stage helps identify varying structural elements and major pressurized fluid reservoirs at medium scales, while at higher resolution identifying lithological strata and geological layering. Several major faults were identified as shown here in two images on the left, while the large image on the right identifies an anticlinal structure that is likely water wet. The initial well, shown in orange color, appears to be low on structure and wet. The blue color was selected to show a water wet zone. This zoom in of the anticline shows that the initial orange well was indeed low in structure and water wet, while the dotted lines depict our interpretation of the anticline and the fault. The two proposed drilling locations shown in yellow and white colors are indeed high on structure. This zoom in of the anticline shows that the reservoir is mostly water wet, irrespective of the structural position. The images and the animation shown here further detail the low structural position of the initial water wet well. This 3D animation shows the structural characteristic of the anticlinal reservoir, the structural positions of the initial and the proposed wells. The white and yellow wells indeed appear to be structurally high to the initial well. However, almost the entire reservoir is likely water wet, according to the STeP visualization of this drillable target. We have integrated the structural map created by the generators of this prospect with the 3D lithological cube constructed using STeP. This integration provides a positive STeP validation of the seismically derived structure. This static image extracted from the previous animation validates the 3D seismic structure map by STeP. The orange well appears to be low in structure, while the yellow and white wells are in structurally advantageous positions indeed. This is the final screen showing the results of this case study, evaluating the STeP interpretation against the GNG data and the drilling results. The summary of the STeP conclusions is as follows. First, the proposed drilling location was structurally high in relation to the initial water-wet orange well. Second, STeP saw the initial well as structurally low. Third, STeP saw the associated anticline and the proposed well being structurally high to the initial well. Next, the anticline is largely water-wet. Lastly, no significant accumulations of hydrocarbons were expected. The drilling results were: the proposed yellow well drilled structurally high, as a matter of fact, 30 feet high to the initial orange well. The logging results uncovered a thin 2-foot non-commercial gas-saturated sand and a 30-foot thick shale section that was dry, followed by a water-saturated horizon. The well was pronounced a dry hole. In conclusion, while STeP and 3D seismic agreed on structure, STeP did not see any meaningful hydrocarbons, concluding that the amplitude anomaly on 3D seismic projected by the geophysical interpretation did not reflect a significant amount of hydrocarbons in the well. To the contrary of the GNG expectations, STeP assessed this prospect correctly as a dry hole. Thank you very much, and we'll see you next time. Bye-bye.